Continuing on with Packet 3, the next thing we have to talk about is extrapolation. And the definition of extrapolation is the use of the regression line for a prediction far outside the interval of x values used to obtain the line. Such predictions are often not accurate. So what this means is that you can't use your regression line to make prediction using values of x that are a lot bigger or a lot smaller than those that actually appear in your data. So a good example of this is from our candy grab activity, and we said that the regression line of that candy grab activity was y hat equals negative 29.8 plus 2.83x. So part A says a new student has a hand span of 22 centimeters. Predict the number of candies he can grab. So we are going to use this regression line to calculate a y hat value for when x equals 22 centimeters. So I'm going to say y hat equals negative 29.8 plus 2.83 times 22. And when I quickly do that in my calculator, I get 32.46, so I'm going to say 32 starbursts. Part B says a visiting second grader has a hand span of 12 centimeters. Predict the number of starbursts she can grab. So I'm going to do the same thing, but this time I'm going to use a hand span of 12 centimeters, and I get 4.16 starbursts. Part C is the most important part of this extrapolation piece. It says, how confident are you in each of these predictions, and explain. And I'm going to say that I am more confident in the prediction for the new student, which has a hand span of 22 centimeters, than the prediction for the second grader, which had a hand span of 12 centimeters, because of extrapolation. Because our data, or our sample, was high school students, and then you bring in a second grader, that second grader doesn't really fit in with our sample. So our prediction based on the regression line was given that we were all high school students. We all had very similar hand spans. Using the hand span of a second grader would be extrapolation because that small x value didn't appear in our data. On the next page, we begin to talk about residuals. And residuals is going to be very important moving forward, because residuals are used to calculate your least squared regression line. So a residual is the difference between the actual value of y and the value of y predicted by the regression line. So basically, the easy formula for a residual is the residual equals the actual minus the predicted. So example number 3 says use the regression line from our candy grab activity, same regression line, to calculate and interpret the residual for a student who has a hand span of 23 centimeters and grabbed 36 starburst candies. So this is going to be their actual y, and we need to calculate the predicted y based on their hand span. So y hat equals negative 29.8 plus 2.83 times 23, and I'm going to change this to 23, and I get 35. So the predicted would be 35 candies. So the residual equals my actual y, which was 36, minus my predicted 35, which would be 1 candy. Example number 4 is very similar. It says the regression line of y hat equals negative 0.31 plus 0.212x shows the relationship between x in temperature in degrees Fahrenheit and y in chirps per minute for the striped ground cricket. Calculate and interpret the residual for a cricket who chirped 20 times per minute when the temperature was 88.6. So the 20 times per minute was going to be my actual, and I have to calculate my predicted when the temperature equals 88.6. So I'm going to use my regression line formula and plug in 88.6 for x. So negative 0.31 plus 0.212, 88.6. And I get 18.4. So we'll just call that 18. So y hat equals 18. So the residual equals 20 minus 18, which equals 2 chirps per minute. So the residual tells you the difference between what actually happened and what your regression line predicted to happen. Part 3 is very important because not only are you going to need to be able to calculate a regression line, but you're going to need to be able to interpret. And so this box right here goes over all the different variables they use in the regression line. So remember, y hat is going to be your predicted value of y. B sub 0 is going to be your predicted value of y when y equals 0, and that is always going to be your y-intercept. Sometimes your y-intercept is going to have context, sometimes it's not. That's a very common question that can be asked on the AP test because they want to be able to see if you know what that y-intercept means, if it means anything at all. B1 means the slope, and it's the amount by which the predicted value of y changes when x increases by 1 unit, and then x is your given explanatory variable. So part A says interpret the slope of the regression line from our candy grab activity of y hat equals negative 29.8 plus 2.83x. So 2.83 is going to be my slope, and I need to interpret what that means for our candy grab activity. So in that candy grab activity, for every increase in hand span, we predicted that a person could grab 2.83 more starbursts. So for every 1 centimeter increase in hand span, a person can grab 2.83 more starbursts. And we say more because you have a positive 2.83 slope, so that means as x increases, so does your y. Part B says, does the value of the y-intercept have meaning in context? So my y-intercept is negative 29.8, and if you think about the unit of y, the unit of y is starbursts. And so if you have a hand span of 0, you could grab negative 29.8 starbursts, and that doesn't make any sense. First of all, you can't grab negative starbursts, and second of all, you wouldn't have a hand span of 0, and if you did, you'd be grabbing 0 starbursts because you wouldn't have a hand. So part B, does the value of the y-intercept have meaning in this context? No, because you can't grab negative 29.8 starbursts. Just not possible. Okay, so the last part of this packet is the least squares regression line. So when we were talking about residuals, we were talking about the difference between your actual and your predicted. And theoretically, you want this value to be as small as possible. You want it to be 0 because you want your predicted value to be equal to your actual value. So what makes a good model to predict future values of y given an x value? So a good regression line will minimize your residuals. It will have a sum of r squared near 0, and it minimizes the sum of squared residuals. So the residuals, if you're looking at this data set right here, and they said our least squared regression line is right here, and it sums the residuals of 0. So your regression line is going to be your line of best fit. You probably learned that in a science class or hopefully in a previous statistics unit in math. But the difference between the actual and the predicted is going to be your residual. So all of these lines going to your regression line are your residual values. And you want those to be balanced out between the top and the bottom because you want your line to be very representative of every single point in your data set. So down here, we've already done this, but it says use technology to find the least squares regression line of the following data. And the least squared regression line is the same as your regression line, and luckily your calculator does it for you. You don't have to calculate any of this by hand, but you do have to interpret it. So you would have to tell me what this y-intercept means, what the slope means, and why it is a good line of best fit. So again, as a reminder, to do this on your calculator, you go Stat, enter for edit, and then you're going to enter your x and y values. So 2, 3, 5, 7, 9, 4, 5, 7, 10, 15. Stat, calculate. We're going to go down to number 8. And we get y equals a plus bx. So y hat equals 0.305 plus 1.52 x. That would be a linear regression, or the least squares regression line for this data set, where x represents the hours of sunshine and y represents the ice cream sold. So to interpret this, you would say that the slope of 1.52 means that for every additional hour of sunshine, 1.52 more ice creams are sold. In the next packet, we will continue working with regression models to make predictions, and I hope you have a great rest of your day.